you. Okay, so we're back again with our lecture lah. Okay, so I hope you're all doing well. So we're back again with our lesson for digital techniques lah. Okay, so in today's chapter, we will be going to electrostatic sensitive devices lah. Okay, so I'll skip to chapter 4 first lah. Later I'll send you the notes for chapter 3. So far we have done chapter 1 and chapter 2 for this topic. In total we have 4 chapters only, for digital techniques. So let me explain chapter 4 first lah for today's lecture lesson today. So as you can see, based on the title, in today's lesson, we'll be talking about electrostatic sensitive devices and anti-static protection. So this topic will cover electrostatic sensitive devices. So it's a short chapter, it's a short topic, so bear with me and let's get on with our lesson for today. So without further ado, let us continue with our lesson, with our new topic today, that is chapter 4, electrostatic sensitive devices. So you know, this slide is prepared by myself. And based on this diagram, you can see this is how electrostatic electrostatic affects our daily lives. As you can see, the static charge build up on our body when we interact with objects around us. Just like this one. Example lah. This is an example of electrostatic discharge lah. This one's the tiny thing that we don't really see. But it happens in our daily life. So that is electrostatic discharge. So let me explain the introduction of electrostatic sensitive devices. So now we're going to jump into the introduction lah. Let me explain. What is ESD or electrostatic sensitive devices? ESD or electrostatic sensitive devices are highly susceptible to damage from electrostatic discharge lah. This is example of electrostatic discharge lah. This one, tiny current lah. These include microprocessors, transistors, and also EEPROMs. So microprocessor, transistor, and EEPROMs are very susceptible to ESD lah, electrostatic discharge. The increasing miniaturization means tiny lah. Small, miniature lah. Means small lah. Making the components smaller, makes them much more vulnerable to lower voltage discharge. Due to them being very tiny, they are much prone to or vulnerable to voltage discharge lah. ESD is defined as the transfer of electric charges between bodies caused by direct or induced by electrostatic field. So this is how ESD is transferred lah. Components can be damaged when charge is transferred. For example, like we see here in this diagram, when charge is transferred, it can cause damage lah. So breakdown of dielectric material within the component happens if not properly discharged. Breakdown means rosak lah, spoil. So the one just now we have entered our introduction lah for this chapter. So you know slightly already what is ESD. So let me explain the main objectives of this chapter. So first, we are able to understand what is electrostatic discharge. So this is the goal for this chapter lah. Next, recognizing ESD risks and the damages caused lah. Third one is importance of control environment. Importance of how to control environment is that will affect ESD lah. Four is proper use of anti-static tools and equipment. Last but not least is safety precautions for personnel. So all these 5 objectives will be covered in here lah. In this topic. Now let's jump into risk and possible damages. So what is risk and possible damages? So let me explain. Static electricity is common and harmful to sensitive electronic components lah. And is common caused by friction. So is commonly caused by friction lah. This static electricity is commonly caused by friction lah. Friction can generate static electricity. Next, as humidity drops below 20%, a static charge builds up on a person's body. So Okay, the faster a person walks, the higher the charge lah. Okay, the more we walk, the faster we develop charges lah, basically. By simply walking on a carpet, we generate 1500 volts of static electricity at 65% relative humidity and up to 35,000 volts at 20% relative humidity. So basically, you generate more as the humidity drops lah. Okay, you generate more static as humidity drops. Plastics used in products can generate from 5,000 to 10,000 volts. Okay, so plastic also generate lots of static electricity lah. Okay. Once the person sits down at the workstation, the electrostatic field around his body is enough to cause serious damage to ESD components or devices without physical contact. Okay, so by you sitting down only, okay, in your workstation, okay, you're able to damage ESD sensitive devices lah without even you knowing lah. Okay. A classic example, okay, is by picking up a piece of paper using a comb, okay, that was rubbed against a fur. Okay, so basically the comb you rub against a fur, then you touch the comb. After rubbing against the fur, you pick up it using the paper lah. Okay, so in this figure, okay, it shows that the comb is charged negative. Okay, meaning there exists an excess of electrons built up on the comb. The side of the paper closest to the comb will end up being slightly positive due to the attraction of opposite charges, while the opposite side will be slightly negative due to the repulsion. Okay, so this is the example lah. As you can see here, this is what we call electrostatic induction lah. Okay, so this is what is described here lah for this one. Okay, next, military standard for ESD control. This one is in terms of military standard lah. Okay, so based on MIL-STD-1686C, which is in the United States military standard for ESD control, states that there are two classes of ESD sensitive items. Okay, this is based on US military standard for ESD lah. Okay, class 1 is 100 to 1000 volts. So for class 2 is 1001 to 4000 volts of sensitivity lah. Okay, most electric components are in class 1. Okay, for example, bipolar transistors are susceptible to ESD between 380 to 7000 volts. Okay. Okay, CMOS devices are susceptible between 250 volts and 3000 volts. Okay, EPROMs used in computer memory are susceptible to as low as 100 volts. Okay, so this is military standards for ESD control lah. Okay, next, anti-static protection control environment. So now we are going to talk about the control environment lah. Okay, so these are anti-static protection strategies developed lah, okay, to ensure a controlled environment. As we know, ESD cannot be eliminated, okay, but must be controlled. The key components of a controlled environment includes 1. Keeping insulating material, for example, nylon, mylar, out of the area of work lah. Okay, so you try to avoid using these insulating materials in your working area. Next, technicians must use anti-static footwear and ground themselves before working with sensitive devices. So this is one of the ways to control anti-static static from in your working environment lah. Okay. So next, static safe workstation. So we have to establish a static safe workstation. So how are we going to do that? Let me explain. Okay, workstation must be grounded via a 1 mega ohm resistor and covered with a conductive materials. Okay, so that is how we have a static safe workstation. Anti-static mats and tabletop mats with specific resistivity are used to ensure protection from static. Okay, workstation should have a static dissipative floor mat and tabletop mat that have a surface resistivity of 105 to 1012 ohms per square inch. So example is shown in the next figure lah here. Okay, so based on this figure, this shows a static safe workstation lah. Okay, 1 mega ohm resistor connected to a common ground point. The resistor is required to protect a personnel in the event the ground becomes electricity electrically alive. Okay, so basically there's a 1 mega ohm resistor connected to a common ground point lah here. So by by having a 1 mega ohm resistor connected to the ground point, basically we're able to ground the electricity lah, any static electricity present lah. Okay, so this is a static safe workstation. Next, anti-static wrist straps. Okay, so what is anti-static wrist straps? Okay, so by using anti-static wrist straps, okay, so basically let me explain. Wrist straps connected to a ground point ensure the technicians are protected from static. So this is the function of anti-static wrist straps. Okay, it helps and protects technicians from static. Okay, proper usage includes ensuring wrist straps maintain skin contact to dissipate electrical charge. Straps purpose is to dissipate charges. Okay, so remember, straps are used to dissipate charges. Remember this. Okay, next is warning signs and visuals. So always provide warning signs for electrostatic sensitive areas. Basically, clear warning signs must be posted in areas handling electrostatic devices. Ensure personnel follow all necessary precaution. So this is the importance of warning signs and visuals lah. Okay, so by having clear warning signs and visuals allows personnel to follow safety precautions lah. Okay, so this is the importance of warning signs and visuals. Next, special handling of ESD sensitive components. So how do we handle ESD sensitive components? Let me explain. Components should be stored in closed conductive containers. Okay, before handling, personnel must discharge static by wearing grounded wrist straps. Okay, like what is explained in the previous slide lah. Okay, soldering irons must be grounded before use to avoid introducing static charges during assembly. Okay, next, packaging for ASD components. Okay, so what is this? What is packaging for ASD components? Let me explain. ASD sensitive components should be stored in a laminated electrostatic shielded conductive bags. Okay, these bags are constructed within multiple layers or metallized outer layer, insulation layer, and anti-static inner layer to protect against electrostatic charge. Okay, based on this diagram, as you can see here, this is an example of laminated metallized bag for storing ASD sensitive components. Okay, so this is how we store components lah. Okay, ASD sensitive components. Okay, so to prevent static from damaging the component. Okay, so any questions? If you have any questions, feel free to ask me. Okay, so we have completed our lesson or lecture for today. Like I said, it's a very short chapter lah. Okay, so we have completed chapter 4 of digital techniques. Okay, we have covered this entire chapter 4 already. So if you have any questions, you can feel free to ask me. Okay, so I think that's all for today for our lesson. Okay, so thank you for your time. Okay, later we will continue with our lessons again lah. Okay, so we'll continue with tutorials and lessons. Okay, so I think it's best I end the class today for now. Okay, thank you for your time. Okay, if you have any questions, feel free to ask me. So thank you everyone. Okay, I'll see you in the next session. Thank you.